Actually, safety is a key challenge today in the hydrogen ecosystem because hydrogen is a gas that is colorless, odorless, and highly inflammable. Leaks are therefore to be avoided as much as possible. Fortunately, physical testing of electrolyzer, bipolar plate, or for leakage, for instance, are very time-consuming. Also, hydrogen needs to be stored at high pressures and structural integrity needs to be maintained for such high pressurization. All in compliance in precise standard, for instance, the ISO 11193. Same here, physical testing of H2 tanks for strength and durability are very time-consuming and difficult to achieve. Today, our simulation and virtual twin solution enable, for the bipolar plate, have a quick evaluation design for structural performance issue and also to have prediction of optimal contact pressure material option, for instance. And also for the storage, we have the capability to have a quick evaluation of design option for structural strength, durability, also to have the capability to do a right choice for material option for the tank and also to optimize the weight of the tank, the dimensions, and the thickness for a best structural performance.
Finally, we talk about several types of simulations. Simulation based on a virtual twin will really help them to work on different scenarios that you could not, or maybe with difficulties, do with physical prototypes, because we talk about structural simulation, aerodynamic, thermodynamic at an equipment or a system level. But also it gives the way to explore innovative or let's say bespoke designs without building costly prototypes, physical prototypes, and expand operating conditions. And those simulations allow the equipment engineering feasibility and also give the way for the team to better identify, of course, with defined use cases, the potential failures of my equipment.
So for today's electrolyzer manufacturer, there is three big main challenges for the performance inside the cell stack. The first one is testing cell stack of electrolyzer for thermal issue is time consuming and impact product design time. The second one is the need to maintain optimal operating temperature for electrolyzer for maximizing product life and thermodynamic efficiency. And the third one is the need to design coolant channel while ensuring other design objectives are achieved. So our simulation solution today ensures to evaluating design for thermal issue quickly, predicting electrolyzer temperature and evaluating different design and material options, and also assure multi-objective design for thermal performance for pressure drop and flow mixing.
On the fluidic engineering, let's say fluidic simulation, actually thanks to the CFD, so the computational fluid dynamics workflows, manufacturers can perform very complex simulations involving the high frequency transient simulations with real moving geometries or complex multi-phase flows, the free surface flows, and also the fluid structure interactions. So this is really important. Simulation teams will be able to identify the issues and work on results, exploration, enabling them to better focus their efforts on the design iteration and potential optimization that they could perform. And on top of that, with advanced rendering capabilities, it really provides realistic visualization and for the people to gain deeper insights into the flow performance, to have a very clear understanding of this flow performance. The users will work on those lubrication workflows, such as we are talking about electrolyzer, the electric motor drives, to get detailed insight into the system performance. And then the lubrication simulation can really reduce the number of physical tests, because we are again in the simulation world. And this is the power of such simulation, because it really provides quantitative predictions for the result. So it could be like for the the oil distribution plot for whatever churning and squeezing loss, but also we talk about the velocity plots for the windage loss. That can be very difficult or almost impossible to measure experimentally.